Welcome to a LeanStacks instructional video. This video is part of the Spring Data Fundamentals series. In this video, we utilize the Greeting Web Services project constructed in the Spring Boot Fundamentals video series to demonstrate three strategies for query definition using Spring Data JPA. There are three principal ways to define queries when using Spring Data JPA. The first are called query methods. When using the query method approach, Spring Data attempts to create a SQL query from the structure of the method names declared on a repository interface. The second approach is to use JPA named query annotations. The annotation is placed on the entity class rather than the repository interface, and the name element value is used to match the query to a repository interface method. The third approach is to use the Spring Data query annotation. The query annotation is placed on the repository interface method to which it applies. By default, Spring Data first determines if there is a query declared via annotation for a repository interface method. If no annotated query is found, Spring Data attempts to convert the method signature into a query. Let's explore each of these in greater detail, beginning with the query method approach. Using the query method approach, Spring Data analyzes the structure of method names declared on repository interfaces and creates SQL statements. Spring Data uses camel case to parse method names into words. Next, it analyzes the words to create a SQL statement. For example, the method findByUsername is determined to be a select statement because it begins with the word find. Entity attribute names used in the where clause follow the word by in the method name. Multiple attribute names are separated with the keywords and or. Spring Data offers several method name keywords to refine the query, such as like, ignore case, distinct, true, false, null, not null, before, after, between, order by, etc. A complete table of keywords is available in the Spring Data JPA reference guide available on the Spring website. The method return type indicates if one or more rows is expected to be returned by the query. A JPA exception may be thrown if an unexpected number of rows are found. Now let's look at a repository interface. Open the Spring Tool Suite and the Greeting Web Services project. Navigate to the org example WS repository package and open the account repository interface. This interface was created as part of the Spring Security Fundamentals video series. Note that the repository has a single query method declared. When Spring Data analyzes the findByUsername method and generates a SQL statement, it's equivalent to the select statement I'm authoring in the comment here. Since the return type of the interface method is a single account rather than a collection of accounts, the method will throw an exception if the query returns more than one row. Let's declare another query to illustrate a few of the keywords which are available. This query method searches for accounts by both the username and enabled attributes. The username attribute has the containing and ignore case keywords applied to it. The containing keyword specifies a like clause where percent signs are both prepended and appended to the criteria. The ignore case keyword indicates that the username search should be case insensitive. The enabled attribute is modified by the true keyword, ensuring that all results have an enabled attribute value of true. Finally, the ordered by keyword is used to sort the results in ascending order by the value of the username attribute. Once again, I will apply a comment to this method which contains an approximation of the SQL select statement which Spring Data will generate based upon this method name. To illustrate these changes, let's create a JUnit test class. In the source main test directory, create a new package named org example ws repository. Within that package, create a new class named account repository tests, which extends the abstract test class. Annotate the class with transactional to ensure that any database changes are rolled back at the conclusion of each unit test method. Before creating the unit tests, let's look at the SQL data script located in source main resources data HSQLDB. Notice that there are two rows of account data inserted into the database each time the application starts. The username values are user and operations. Let's use that information to create some unit tests. I'm going to paste in the contents of the class and we'll walk through the code. Use the auto-wired annotation to inject an instance of the account repository into the test class. The first unit test method demonstrates the find by username query method. The value user is passed as the method argument and therefore used as the query parameter value when searching the database. The first assertion validates the returned account entity is not null. The second assertion verifies the returned account's username attribute matches the value supplied as the query method parameter. The next several methods test the more complex query method with various query parameter values. The test find by username like method invokes the repository query method with a parameter value of ER. Since the database contains usernames of user and operations, we expect the query to return both rows. The assertions verify the returned collection is not null and that it contains two account entities. The third test method illustrates the ignore case keyword. Notice the query parameter has been set to mixed case ER. We expect the query to return two rows again because the query should be case insensitive. The assertions validate those expectations. The fourth and final test method supplies a mixed case value of USER as the query parameter. Since this should fail to match the username operations, only the row whose username value is user should be returned, and the assertions expect the collection size to be 1. Let's run the JUnit class in STS. In the Package Explorer, right-click Account Repository Test Class and select Run as JUnit Test. The results are displayed in both the JUnit and console views of STS. All of the tests were successful, indicating that the queries created by Spring Data from the method names in the repository interface behave as we expected. The second approach for defining queries in an application is to use the JPA named query annotation. Spring Data uses the value of the name element to match the named query to a repository interface method. The name value should be the entity name followed by the repository interface method name, separated by a dot or a period. The named native query annotation may be used to define a native SQL query to take advantage of database platform-specific features and functions. However, use native queries only when necessary, as the application will become tightly coupled to the database platform and therefore will lose portability. Let's look at the account repository interface again. Declare two new methods which we will associate with the named queries. Notice that STS flags the methods as errors when I save the interface. This is because STS is unable to convert the method signatures to SQL using the query method approach. Unfortunately, STS does not search for matching named query annotations. These error messages may be disabled in the STS preferences. Open the preferences and navigate to Spring and Validation. Uncheck the Data Validator item. Unfortunately, if you use a combination of the query method and named query approaches, disabling this validator prevents STS from flagging invalid query method signatures. Next, let's annotate the entity. Navigate to the org example WS model package and open the account class. Above the class declaration, use the name query annotation to create a JPQL query for the find by username named query repository interface method. Next, create a second named query for the second repository interface method. Notice that when multiple named query annotations are declared on a single entity class, they must be nested within the named queries annotation. To illustrate these changes, let's update the JUnit test class. Open the account repository test class. Copy the 4 test methods and paste them at the bottom of the class. We simply need to revise these methods to test the 2 new repository interface methods which utilize the name query approach. Update the names for each unit test method. For each test, modify the logic to invoke the appropriate named query method on the repository interface. For each test method that executes a SQL-like query, update the query parameter data with %signs. When we use the query method approach, Spring Data automatically generated the %signs for us based upon the keyword that we used. However, we must programmatically prepend and append %signs when using named queries. Let's run the JUnit test class in STS. Return to the JUnit view and execute the account repository test class again. The results are displayed in the JUnit and console views. All of the tests were successful, indicating that the named queries tested in the 4 new unit tests behave as we expected. Not only were the tests successful, but they proved that the repository returned the same results with both the query method and the named query approaches. The third approach for defining queries in an application is to use the Spring Data query annotation. The query annotation is placed directly on the repository interface method to which it applies. This is a much cleaner approach than annotating entity classes with named query. It creates a greater separation between the entity model and the repositories. The entity classes are responsible for modeling the data structure. The repositories serve as a data access layer. Therefore, it's more appropriate that the queries be defined in the repositories. The query annotation can simplify like queries by parsing the JPQL for %signs and prepending or appending them to the query parameters during execution. However, this does not work in all scenarios. For example, when functions are used to facilitate a case-insensitive search, Spring cannot properly parse the %signs. By annotating repository interface method parameters with the param annotation, you may use named parameters in query annotated statements. Supply the query parameter name as the value of the param annotation. Let's return to the account repository interface again. Declare 2 new methods which we will annotate with query. The method parameters use the param annotation so that we may use named query parameters. The repository methods are each annotated with query, whose value is a JPQL query. You may also use the query annotation to create native queries. Simply use the native element within the query annotation. The value of the native element should be set to true if the value of the query annotation is a native SQL query. To illustrate these changes, let's update the JUnit test class one final time. Open the account repository test class and copy the 4 test methods. Paste them at the bottom of the class. Revise these methods to test the 2 new repository interface methods which implement the query annotation approach. Update the names of each test method. For each test, modify the logic to invoke the appropriate method on the repository interface. Let's run the JUnit class in STS. Return to the JUnit view and execute the account repository test class again. The results will be displayed in both the JUnit and console views. All of the tests were successful, indicating that the query annotation approach tested in the 4 new unit tests behave as we expected. Not only were the tests successful, but they proved that the repository returned the same results using all 3 of the different query definition approaches that we have illustrated. In this episode, we have seen the 3 primary ways to create queries using the Spring Data JPA project. The query method strategy allows engineers to take a minimalist approach. With a substantial and powerful set of query method keywords, it's possible to create complex queries without writing a single JPQL or SQL statement. However, there are times when the query method approach does not meet the requirements or becomes a bit too complex. Spring Data integrates seamlessly with the JPA named query annotations. If you are migrating an entity class library from a different ORM framework to the Spring Data JPA framework, it may be simpler to keep the existing named queries, at least initially. One potential negative of the named query annotation is that they're declared on the entity classes rather than within the data access layer of the application. From a pure application architecture perspective, this commingling of data access logic with the data model demonstrates poor cohesion or separation of responsibilities. It's the responsibility of the data access layer of the application to query the database. The entity classes should simply model the data, not perform behaviors on that data. Spring Data's query annotation provides a compromise. By applying the query annotation to repository interface methods, the data access logic is contained within the appropriate layer of the application. The query annotation approach supports native queries in addition to JPQL. Repository interface method parameters may be annotated by param to denote them to be named query parameters. Whichever approach is best suited for your application project, ensure that you define a standard strategy for data access. Having a standard in place ensures that the application engineers use the same approach authoring data access logic, increasing the readability and maintainability of the application over time. I hope you have enjoyed this video. Subscribe to the LeanStacks YouTube channel and follow the LeanStacks Google Plus page to receive updates as new videos are published. As always, you can find more information on LeanStacks.com. To view the complete repository illustrated in this video, see the GitHub repository URL in this video's description.